So now let's just talk about prime numbers, and it'll get us into the idea of lowest common multiples and prime factorization. So what's a prime number? Prime number is anything that's divisible by 1 and itself. So 2 is a prime number because 2 is divisible by 1 and 2. 3 is divisible by 1 and 3. 4 is not because 4 is divisible by 1, 2, and 4. Those are 3 numbers, not 2 numbers. So you skip 5, 7, 11, and 1 is not a prime number because it's only divisible by 1. That's not 2 numbers. So 2 is really 2 times 1. That's 2 numbers. 3 is really 3 times 2 numbers. 4, you can show that as 2 times 2, so it's divisible by 2, or 4 times 1. So it's divisible by 2, 4, and 1. So you can't have that. It's more than 2 numbers. So that is not a prime number. Now the prime factorization. The prime factorization is basically another way of stating the results of the fundamental theorem of arithmetic. This is just an extra for those that want to know. Fundamental theorem of arithmetic just says that any number you have, any natural number, any whole number, it could be anything. It doesn't have to be a prime number. So let's just say you have a number A, whatever it is. That is made up of multiplying. You know how 2 was really 2 times 1? It's just multiplying numbers out. Any number you have, you can represent it as multiples of prime numbers. So this prime number times this prime number times that prime number, that prime number. That's not really an intuitive thing. It's just something you just develop by theory. So for example, any number, choose any number. So 21. So let's write and to really show uh, what are the multiples of 21, you just keep breaking it down into whatever is easiest for you. So you'll look at 21 and you'll see, hey, 21 is a multiple of 3. So 21 is really 7 times 3. Now 7 is a prime number, so you stop there. 3 is a prime number. So the prime factorization is 7 times 3. That's the prime factorization. So just showing that it is multiplying multiple prime numbers, and that's essentially what the fundamental theorem of arithmetic says. It says you can take any number, 21, 207, whatever it is, and it would be a multiple of prime numbers. Now they can repeat. It could be like 3 times 3 times 3 times 11 times 2, but those will always be prime numbers. So let's just do another one. 54. Okay, you see 54 is divisible by 2. That is 27 times 2. Well, 2 is a prime number, so we'll stop there. Look at 27. Is 27 a prime number? Well, eventually you'll realize that 27 is divisible by 3. If you just punch that in your calculator, it's really 9 times 3. So we'll stop here on this side. So now break 9 down. You just keep breaking down into lower amounts. 9 is really 3 times 3. So that's what we have. So now the prime factorization of 54 is 2 times 3 times 3 times 3. Or another way of showing this is really 2 times 3 cubed. You're just saying that you're multiplying by 3 times. And that's all there is to prime factorization. And it's just a product of the fundamental theorem of arithmetic. That just says, like for example, I took a random number 54. You can do this with any number, whole number. You can show that it can be produced by multiples of all prime numbers. Those are all prime numbers. 2 is prime numbers. 3 is a prime number. Moving on. So from that you can do or another way of saying is one result of prime factorization is it makes it a lot easier to find lowest common multiples of numbers. So I want to find the lowest common multiple of, let's just say, 12 and I don't know, 15. So basically what I'm saying is, multiples of 12. So 12 times 1, 12, 24, 36, 40, and then you keep going out, 15, 30, 45, 60, etc. So when do I reach the point that, the same numbers are produced on both sides? So 12, let's just say it reaches some number like 60. So, you see 60 on both sides. You're like, okay, the lowest common multiple, because it's the lowest. It's the first one you found was 60. You just need a number that repeats on both sides. So, you just find the prime factorization of both. So, we know that 12 is, break it down, so that's divisible by 2. So, by 4. So that's 4 times 3. So, you stop there because you have a prime number. And 4 is divisible by 2, so it's 2 times 2. And you stop here. Now, let's work with 15. 15 is 5 times 3. And, we stop here too because they're prime numbers. Now, to find the lowest common multiple of these, you essentially just take what numbers have been represented so far. So we have 2. It can be on both sides, it can be on one side. We just want to see which numbers came up. So 2 came up, 3 came up, and 5 came up. Now you see how many times they came up, and you only deal with one side. So you deal with the side that they came up the most, and you write it down. So for example, 2 came up twice on this side. Let's just say if it came up once on this side, we would not care about that one. We just care about the most times it came up. So 2 came up twice. 3 came up once on each side, so that's the highest one. And then 5 came up once. So the lowest common multiple is essentially 2 times 2, because it came out twice. So 2 times 2 times 3, it came out only once, times 5. That is equivalent to, 2 times 2 is 4. 3 times 5 is 15. So yeah, that's 60. So if you keep this going, you're going to reach a number. You're going to reach 60, and that's what you do. And that's the lowest common multiple because it came up first in both. If you want to do another number, so let's just say, I don't know. I want to keep it small. Not 12. We'll just use that. 14 and 25. So you know that 14 is really 2 times 7. And then 25 is 5 times 5. So now, same procedure, lowest common multiple. So what numbers came up? So 2 came up, 5 came up, 7 came up. Now, how many times have they come up the most? So look at the left side. 2 came up once. That's the most times it came up. 7 came up once. And 5 came up twice. Now, if let's just say this side had like a 5, you don't use this 5 in the lowest common multiple because this one, it came up twice. This one only came up once. You want to use the side that came up the most. So now the lowest common multiple is, 2 came up once over here times 5 came up twice. 7 came up once. So, you punch that in your calculator. 2 times 5 times 5 times 7. And you get 350. That is the lowest common multiple of 14 and 25.